In this chapter, we begin our study of trig functions. Trig functions appear throughout physics in different applications. These very common functions also appear in calculus, differential equations, and probability theory. These types of functions are very useful for modeling oscillating objects or objects that have a repetitive motion. One such object is the motion of a spring. Let's go ahead and imagine the following scenario. Suppose we have a spring. That begins at rest. And then you take this spring and you pull it down and let it go. Then we can track the displacement from the starting point over time of the spring, and what we'll see is that this particular displacement is oscillating between two different values, and as time continues on, these values grow smaller and smaller. We can model this type of behavior using trig functions. Let's go ahead and draw a graph of what this displacement graph would look like. In the graph, we see that over time, our spring is stretching, but each time it stretches a little bit less and less until at the very end, it no longer stretches anymore and returns to rest. While we'll see the equation on how to model this type of behavior, the derivation of this formula, it will be left to an ordinary differential equations course. Throughout this chapter, we'll use the unit circle to evaluate and study trig functions. In the first few sections, we'll go ahead and define what the unit circle is. On this page, let's go ahead and draw a representation of the unit circle. First, here's the xy plane. Then here's a unit circle. This is a circle with the center given by the origin in radius 1. While we think of points on the circle as points living on the plane, the unit circle appears in different forms in other areas of mathematics. For example, as complex numbers or as unit vectors in linear algebra. And before we introduce the unit circle, we're going to go ahead and review section 6.1, angles.